In this video, we're going to talk about forces. A force is another physical quantity that we can talk about, but we cannot see. It's not tangible and we cannot see it. But what we can do is see what it does. So we define a force as a push or a pull upon an object resulting from the object's interaction with another object. So it's not something that the object has or contains, but it is exerted by one object on another. So examples would be to open a door, a force must be applied, or to open a drawer, a pull force must be applied. So there's some pushes and pull forces. How do we measure forces? We measure them using a force meter or a spring balance, which looks a little bit like a fishing scale. And it has a spring that stretches as the weight of an object pulls on the spring. The SI unit of force, we've talked about this before, is the Newton, and the symbol is a capital N. We've spoken about this when we did weight and mass. Weight is, of course, a force. If you attach a mass of 1 kg to this metal hook on the force meter or spring balance, it should show a reading of 10 newtons. That's remembering our weight equals mass times gravity. So we're going to discuss different types of forces and talk about what they are and what they do so that you can better identify them. There's several types of forces, and these forces fall into two categories. They're either contact forces or non-contact forces. A contact force occurs when the object exerting the force touches the object that the force is acting upon. So some obvious forces, applied forces, which are any forces where one object pushes or pulls another object, mechanical or otherwise. Friction, strain, air resistance, water resistance, and lift or buoyancy. There you see a contact force where the ball, because of its weight, is pushing on a mattress and changing its shape. A non-contact force occurs when objects don't touch each other, but they still exert forces on one another. These are electrostatic forces, magnetic forces, and gravitational forces. Even if you jump above the earth, when you're not in contact with the earth, you are experiencing a gravitational force that pulls you back down to earth. And you know, if you have a magnet, you can feel it pulling as you, maybe a fridge magnet, as you bring it close to the surface of the fridge, the metal fridge. Those are non-contact forces. And there you can see a magnet attracting objects that are far away, even though it's not in contact. Gravitational force and weight. We've talked about weight. Gravitational force is the force of attraction between all masses, especially the attraction of the Earth's mass for bodies near its surface. Gravity is such a large force because the Earth is a large mass. The weight is the force an object exerts on the surface of the Earth due to its mass. So we remember that weight equals mass times gravitational field strength, or W equals mg. We learned that in Form 1. There is gravity acting on an apple, and when it is pulled towards the earth, it falls out of the tree. Okay, and there, between our moon and the earth, gravity holds them a specific distance apart, and the moon rotates around the earth. The normal force. Any force that is applied, like weight on a surface, has an equal and opposite force called the normal force, pushing back up. This force exists when two surfaces are in contact, and it keeps the object stable. In other words, it prevents it from falling through. For example, if you're sitting on a chair, the normal force prevents you from falling through the bottom of the chair to the ground. Next, we have applied force, and there are different objects that apply force. Here you can see a man applying force to a weight, and a digger applying force to a pile of sand. Applied forces are any forces that are applied by an object or a person or a machine on another object. Okay, it can be mechanical, for example here, or tractors and bulldozers. There you can see the force exerted as the fuel burns. Electrostatic forces. They are, as they sound, electro, to do with charges, static, stationary charges attracting each other. And we learn that like charges repel. You can see the two positive charges repelling and the negative and positive attracting. Opposites attract. So it's always forces between charged objects. The next one is magnetic force, the force that exists between a magnetic material and a magnet when the material is within the magnetic field. They can be attractive or repulsive, and we're going to go on to deal with magnetism in more detail, but we learn that north poles attract south poles, but like poles, so opposite poles attract, and like poles, south and south or north and north, repel each other. Next, we have frictional forces. There is friction between solid surfaces and objects that are moving, between gases. This one here is air resistance, and also between liquids and objects that are moving. So frictional force is any force that exists between two surfaces and opposes motion. Okay, the force that opposes motion, acts against motion, is called friction. And here we see the rock and the feather experiencing air resistance, a specific type of frictional force. Water resistance also occurs between any object that is moving through water. There you can see a frictional force, and you can see it highlighted. If the surface is rough, then there is greater friction. If we put some water on that surface, or maybe some dishwashing liquid, you would find that the wooden block would move more easily.